Hey everyone, welcome back. In today's video, we're going to continue reaction kinetics and we're going to talk about some graphical analysis. Because in questions related to the rate of reactions, graphs are really important for us. So when we are confronted with graphical analysis, there's one thing which is the initial rate method which is expected out of us, and the other thing that can be expected out of us is half-lives. In today's video, we're going to concern ourselves to the concept of initial rate method. We'll see what it is and how is it related to the analysis of a graph. This method involves the measure of the rate of reaction at specific at a very specific concentration of reactants. So for example, here we draw tangents. So by drawing tangents, we will look at the rate of reaction at specific concentrations. When we talk about the half-life, so we should define it at least, that half-life is the time required for the concentration of obviously reactant, for the concentration of reactants to become half of their original value, to become half its initial or original value. Let's look at this question. It's talking about benzene diazonium ion, which is reacting in a first order. So here rate is related to benzene diazonium concentration raised to the power 1. The order is 1, so I'll write that order with respect to benzene diazonium is 1. You can see as the concentration is decreasing, the rate is also decreasing. The gradient is decreasing for this graph. So here, initial rate method will involve using tangents. Now what I'm going to do is, I'm going to find out the rate of reaction at 0th second and at 100th second. So I'm going to first find the rate at 0th second, which is initial rate. How will I do that? I will draw a tangent at the graph at the 0 time, and then I will find the gradient because the gradient will tell me the rate of reaction. So when I draw a tangent, this tangent has two x-axis points and two y-axis points. Let's say y2, which is the higher value, is 0.020 concentration, and at y1 I have 0.011. You can pause the video to see how I found that on the graph. My x1 value, which is initial time, is 0th second, and if I draw a construction line, my second x is equals to 80th second. So I can see the concentration changed between these tangent values from 80th second, and the initial time was 0th second. We know the value, we know the formula for gradient is y2 minus y1 over x2 minus x1. So 0.020 minus 0.011 divided by 80 minus 0. When I solve it, it becomes 0.009 over 80, and I find my rate of reaction to be 1.125 exponent minus 4 concentration per unit time. Now at 100 second, I will draw another tangent with a red line. For this tangent also, I will have two y points and two x points. Once your tangent is drawn correctly, let's try to find out some specific points which we can read easily. So this is my first point with a cross. I will have to find the y value and the x value at these points. And I will also place another point to find, for example, this point seems easily readable. So I will make a triangle for you guys to understand it clearly. And I will make shading in this area to see that this is my tangent triangle. Let's write our values here only. Yeah. So my y2 is going to be 0.015, and you can see my y1 is going to be 0.008. Yes, you can pause the video again to see how I found these points, by the way. If I look at the x values of my points, you can see that my x2 is going to be 160 seconds and my x1 is going to be 40 seconds. So the concentration changed within these 120 seconds from 40th to 160th. So at 100th second, the rate was equals to y2 minus y1 over x2 minus x1, which is 0.015 minus 0.008 divided by 160 minus 40. When I solve it mathematically, my rate of reaction turns out to be 0.007 over 120. Let's put it in calculator and find out the rate of reaction. By doing that, it becomes 0.5833 exponent minus 4. Now you can see I have two rates of reactions. The concentrations were different, the rates were different. At 0th second, when I found the rate, the concentration was 0.020. And at 100th second, I can also see that my concentration was almost 0.0115. You will have to pause it to see if you can read this value from the graph. At 100 second, the concentration was 0.0115. The initial concentration was at 0th second and this new concentration was at 100th second. I have found my rate of reaction under both circumstances, 1.125 exponent minus 4 and 0.5833 exponent minus 4. You can see that the concentration is changing, the rate is changing. If I find a ratio of the rates with the ratio of concentrations, and if I put the exponent of the order of reaction, let's call it x. Don't forget to put the exponent because orders are always there. So if I find the ratio of rate and relate it to the ratio of concentration, I will see that there's going to be some order related over here. Let me put these values. For concentration, I have these values 0.02 over 0.0115 raised to the exponent x, which is the order. By solving it, I get to know that my ratio is almost similar to my ratio of concentrations. This shows me that the order is almost 1. So we can be asked to prove how it's a first order reaction by drawing two tangents, finding the rate and relating them to the concentration of reactants. I hope this idea is clear to you guys. Stay tuned.